Vamos lá. Hey guys, we are
Hello, Alan.
starting. Hello,
Hello everyone. Hello Alan. Hello Rodrigo.
hello Jorge, hello Jorge. How to say your name in English? In English, Jorge.
I don't know.
I don't
I
know.
think it's Jorge.
Jorge
Uh,
Yes.
and Rodrigo.
yeah. Usually the guys try to, I think the DRI is a little difficult for English speakers, so they said something like Rodrigo or some. I a lot
Yeah,
of different pronunciation I have
yeah.
listened.
It's not so common, right?
Yeah, not
But
outside Brazil, but in Brazil, a lot of.
yeah. Hello, Alison.
Hey everyone, how are
Hi.
you doing?
Fine. How are you doing?
I'm good. Thank you for asking.
Great. So, Rodrigo, what is your plan for today? And could you please show what sensor we are planning to use?
Sure. So today you are going to add support to our board to the ultrasonic sensor.
Mm-hmm.
Is the ATSR04. I think that's it. Maybe you can Google something about this sensor here. By the way, there is a excellent video from you in the NuttX channel, uh, teaching how
To use it, right?
to use it in the I think F1 minimal board,
Yeah,
and that's from where I'm going to get the code and the information to add support in our board.
right.
So yeah, that is okay. So is that sensor right? Is ultrasonic sensor.
Mm-hmm.
Uh, Sorry, there's something here in Portuguese because my browser is configured to Portuguese.
Yeah, but
But that is the I think that's a common sensor that the
uh,
usually the bakers and the guys that
yeah,
play with Arduino
Arduino
use that.
guys developing small robots uh,
Yeah, the
for
little
wheels.
cars, right?
Yeah, for wheels robots, cars. Yeah.
Okay, so the plan is to add support to this sensor. And here is how we connected that.
Mm-hmm.
We can get back this in a while. Let's start from the code and you can then go back to the wiring uh, later. Here I just check out the master.
Mm-hmm.
Uh, I get the latest from the upstream I think last night, so it should be a little older, but not so much. So I may don't have any problem to push it and have any conflict. So let's start here. Uh, so as I said, the the F103 minimum board has support to it. And in fact, Alan, the support is I think the support was moved to the common.
Yeah,
So here in the common we have uh, in
the
fact here,
common
here,
source
yeah, yeah. So
STM32F401RC.
here we have the the support for this sensor in the common. So we are going to use this.
Mm-hmm.
Uh, but
Yeah,
let's start from the. Oops, I think I missed it here. Just a
yeah,
second.
you're bored.
Yeah, here. Sorry. Okay, so let's start by getting the initialization in our bring up here. So if you go here in the F103 minimal board, you have the bring up, and here is I think that's all the code. Let's see. 8 CSR04. Yeah, so you have to include the .8, right?
Mm-hmm.
You can do this in our, let's go to our board. There's a lot of config here. Our bring up is here. So I'm not seeing very well here because the sun is, okay. I can see here. Okay, now I can see.
Yeah. Alice or George, how is the sound, the audio quality in the YouTube? Rodrigo, you removed the ND from
Oops,
the
yeah,
RNDs.
sorry. Okay,
It's okay.
It's okay?
The audio is okay.
Oh, thank you.
so I added the .8, and now I need to add the initialization itself, right? So
Mm-hmm.
let's go back there and get the if config sensors. Okay.
Alan, I don't know if I'm wrong, but I'm guess you edited this driver. You are first guy to edit this driver, don't you?
Yeah, this was one of the first drive, not the first, but maybe one of the sensor drive that I did, and also I create a blog post explain how I create this driver, so it can be useful for other people um, using it, for example. Yeah,
Yeah.
and this driver is really nice to do because it's mostly a pulse, so we need to measure the length of the pulse or the pulse width. Yeah,
Yep, nice. And this driving working with interruptions, right?
yeah,
Or using pulling of
yeah.
interruptions.
uh, Rodrigo, you show how it is done. Yeah. I think,
Okay, so
yeah,
so
this
that
is,
that is the blog post, right? That is the video that
yeah,
I watched.
that's the video, and there is other post. If you just search for this, yeah, created the
That
driver.
one.
Yeah, this one explain
Okay.
how the driver was implemented, and it is very useful. If, for example, other people want to know how to create some driver that need to measure uh, the pulse with this word in English is very difficult to say because
Yeah.
the DT8 with
Yeah.
with and yeah, the let put it this way, the pulse length of uh, the signal that you want to measure, so you can mm, use the when the pulse goes, the signal goes up, and when this go down, so you have the distance, the bit in the time when it start and when it finish. So it's really cool to use it.
I just want to show one thing here in the video.
Mm.
Some experiments here,
Yeah, showing it working.
and it's very nice because you can see that it's very precise. Like here, you can see 25 inch, and from the calculation here, you can see that's exactly the same. So when you
Yeah,
start to a little near to the, let's say 20 now, and
yeah.
it's very nice.
I was surprised about the quality of this sensor, because I thought, oh, it's not. It should be very um, the quality of the sensor, the distance return should be very far from the real distance, but it's not. It's very good. actually.
Yeah,
Yeah.
yeah. Maybe you should get this to in the introduction, but sorry to interrupt the coding. Let's go back to the code.
Yeah, no problem.
So, so here is the initialization. So in in our the Bing wrap for our board, we added the .8 that's
Hmm.
from the common and the initialization. And I think we need now to go to the board.8 and add the definition for the pins.
Yeah, but
But
before
for
that, I suggest you go back to the common and show what is expected inside that initialization. So people you understand they need to define these signals, right?
okay, that so I think this part maybe you can help
Yeah, sure.
if a little more. Okay, let's go there. Board. I think it's open here. Yeah, it's open
Yeah,
here.
it's already open.
So you can guide me here and let me know which function or which part of the code you want to
Yeah,
show.
you start for the board initialization, the
Okay,
that function that is called.
uh, initialize
No, no, I don't remember. Yeah, this one.
this one.
Yeah.
Okay, so input parameters, device the device number.
Mm-hmm. Yeah. So it is start initialize configuring the interrupt pin and the trigger pin because this sensor first before measure you need to trigger GPIO to indicate I want to measure. So you send a pulse, a small pulse to indicate you want to start the measuring, and then the it will generate an interrupt when the signal start and when the signal finish.
Okay,
So we need to define these two pins, right? The
okay,
interrupt pin and the trigger pin.
and okay.
Mm-hmm.
Could you tell me about this free
Free
run
run.
timer?
Yes. Um, a free runner timer is a normal timer that instead of generate interruptions or generate alarm or so on, it just count. So
Okay,
you configure the timer to, for example, if you define the timer um, to increase 1 unit each 1 microseconds. So if you sorry, there is a lightning, some thunder
yeah.
here. I don't know if you
we
listened. Very high, very
we do.
yeah,
Yeah.
very strong here. Uh, so imagine it is counting each 1 microsecond, and then it, for example, if now the value is 10, and then it's you read it now, and few microseconds later you read it again, and now the value is 15. So you know from the beginning to the second time when you read this timer again, uh, 5 microseconds passed, right? Or
Okay.
0 for 1, 2, 3, 4, 5. So
Hmm.
this is the elapsed time between the beginning, the start, and the end. So the timer, the free running timer, is used basically for that, for timing or timing measurement.
Hmm. Perfect. Makes sense.
Yeah. So
Okay.
yeah. So
So
let's start for the pins, right?
okay, let's configure the pins. So again, I go to the minimum and check here for the.
Mm-hmm.
Okay, so here is the pin definitions.
Right.
I will change. something here. Otherwise, will not work. Okay, let's go back to our board. Let me close this one. Our board.8, and I can put anywhere here. I think I'll put buttons. Okay, where is the quadrature? That's okay. I put here. Okay, so now we need to do some changes here.
Mm-hmm.
First, let me see the, because here they are using port A, pin 1, and port A, pin 0. But
Mm-hmm.
let me check our connections here. I put the, okay,
And also maybe you can change it if these pins are used, for example, in our board for some other purpose. So we can check the schematics to confirm.
yeah, let's do that. So, uh, in fact, I I changed already because I was using the same one that USB,
Mm-hmm.
but I can show you.
Okay.
So in my first try, I was using the PA10 and PA11, but it's clear being used for USB. So
Mm-hmm.
that's not the. Now I'm using the PB0 and the PB1, and since not being used for any of the other
For
systems here.
right. Another way to confirm it, you can go inside the board pin, the STM32F401RC RS485.H, and verify,
Hmm.
for example, search for uh, port 0 and port 1. So if there's some other uh, applications using it, you see the port 0 in Jeep, for example, port port A pin 0, port A.
You mean here, like,
Yeah, search, just, yeah, press
or
enter.
port B? Let's see, port B being used the 30,
Yeah,
40,
right.
14,
But
15.
you use port B or port A?
B,
B.
port B.
Okay, okay.
Yeah,
So since port B 0 and 1 are not used, right?
yeah. Not here.
Mm-hmm.
Let's see in the port 8 itself. No, there's no results. Okay, so
Okay,
port B. Then
is
let's
safe
change
here.
here first for port B. Uh, okay, port B here.
Okay, so just to confirm, the interrupt will be PB0 and the trigger should be PB1.
Let me double check this in the.
Yeah, because if it is inverted,
Uh,
it will not
yeah.
work.
So I think it's a little difficult to you guys to see, but the orange
Orange.
pin is in the trigger.
Mm-hmm.
So is the PB0 in the trigger?
Oh, so it's inverted in your code,
Yeah,
right?
yeah.
Yeah, you need.
That's so is here is maybe I can
Yeah, just change the pin 0 and pin 1 position. You
pin
don't.
one here. Okay, P0 here. Okay, but that's not well. We need to also change it here because seems like these definitions is valid only for F1 and not for F4.
Ah, yeah,
So
that's true.
I think one that we did was the
Yeah.
speed.
Actually, I don't know why they didn't use the same pins name because it's the same architecture, right? Uh, it's not F4, it's a F1, but inside ARM, source, STM32, they are basically the same. But
Hmm.
yeah, maybe it should be modified in the future to have only one definition.
Now, this one here, do you know which? I found the GPIO float.
Hmm.
And I'm not sure if the same that is. I'm
Now,
not sure.
the simple way to find it is go back to the board, the STM32RC .h, the file that we are looking few time
Uh-huh.
few seconds ago, and
Uh-huh.
yeah, and just search for some input. For example, buttons are using it. Is the GPIO float actually?
Okay,
So
GPIO
my
float.
suggestion is just to just copy this line and replace the other one. Instead of copy just GPIO float, just copy the entire line. Yeah,
Mm-hmm.
the parentheses as well. You
Okay.
you can copy everything.
Okay. And replace here
Yeah, just
entire line. Just to put then the pin one here, right?
mm-hmm. Yeah,
And how about this? Because this has this
output clear. Uh,
yeah,
there is also the clear and set there, so you can remove this line and
okay.
yeah,
I can paste the
yeah, you can remove here and go back there and copy one. No, this is for
oh,
input.
okay.
Just
Okay, sorry.
just remove, yeah, and
Mm-hmm.
go back there.
Let's go back.
And yeah,
Uh,
now you want
fi-
search for some output, maybe some LEDs. Yeah, this one is okay.
mm-hmm.
Yeah,
Okay. Let's copy here. Let's copy here, and I need to. Oops.
yeah. If you want, you can also change the position. For example, you can
Yeah.
move port C to the end to make it more similar.
Just a second. Just why did this? Okay.
Mm-hmm.
Okay.
Okay.
Let's first put here.
Yeah, align it.
Not sure they use two tabs here, two for 80 space.
No, no. Normally,
No.
you just put it below the GPIO port C, for example. You just align the G
Okay.
from the
Hmm.
previous line with the G. Oops. Just remove.
Yeah.
Yeah, just put one below the other. Yeah, just like
Okay. I'll put this in the. So I
to
need
the
to
end.
first put here PB,
Mm-hmm.
and here are you going to use pin 0.
Yeah.
Uh, Let me do something here so you can see the entire line. And I want to copy this to the end
Mm-hmm.
so you can see the. Okay.
I suggest you to remove, press Ctrl Z and move the
Hmm.
speed line to that position as well, and put it the GPIO port B at the end. Uh, you don't need to break the line. You can put everything in a single line.
Okay, so put this.
Remove the press Ctrl
Hmm.
Z to yeah. No,
Hmm.
no, don't. Just remove this beginning part.
Okay.
Uh, yeah, and now move the the bottom line to the end. Yeah, remove this symbol, this
You
yeah
mean this, right?
slash backslash, and
Okay.
exact, and put the port at the pipe and the port.
It's missing a pipe here.
Mm-hmm.
Okay, and let me fix this space here. Okay, so it's a little big, but
Yeah, I think now it's
it's,
okay. Yeah.
it's okay. Okay.
You keep it pipe in the end. Also, you need to remove that.
Oh, yeah. Whoops. Okay. So that's all,
Yeah,
right?
yeah. For the pin configuration is okay.
And I don't think you have anything else in the to configure. Do you remember anything else that we need to
Mm,
configure?
no, I think that's okay.
Okay.
Um, Now, for example, see, it's use the timer three, use timer three, channel one and two. It's for other thing, right?
No, no, yeah. So that is
Yeah,
it's just this one here. So they are using the
timer
timer
one
timer one.
as free
Yeah.
running. Okay,
Okay.
so I think now it's only configuration in the menu config.
Okay. So I shouldn't should okay. Let me make this clean. Okay. Let's configure. Not yet this one. USB NSH. USB NSH. Okay, so now make config. Okay, let's see if I remember here. First thing I think is system type,
Mm-hmm.
STM32 peripheral support,
Yeah,
enable timer one. Okay,
yeah.
go back.
Chin one. Okay. N-
Now timer configuration,
yeah,
right?
yeah,
And we need timer free running wrapper. Okay,
yeah.
and that's it here. Board selection, we need the common board
Co-
logic
right.
because we are using the common there, right?
Mm-hmm. Correct.
Okay, and I think
Yeah, device driver.
device drivers, uh, timer driver support. I don't remember this last one. Let me check here if I have some. Uh, okay, I didn't remember this last one.
Yeah,
Help me.
you can enter there, but I don't remember also if we need if there's some free
Uh,
running. Is one
no,
shot
I don't.
we don't use.
Yeah.
Okay, I think we
No,
don't need the timer drive directly because we only need the free running wrapper, right? So
oh,
yeah, another thunder.
yeah. So in my,
Yeah, now you can
my
go back to no, you can go back and select
you
the
can
sensor.
just to double check if I did everything because
Mm-hmm.
uh, if I missed someone. So timer one is enabled, free run is enabled.
Mm-hmm.
Ah, the sensors.
Yeah.
I was trying to remember. Okay,
Now you go
it's
inside sensor, you select the distance sensor, ultrasonic
yeah,
distance. in the
is,
bottom.
yeah, sensor device drive support. Uh,
Mm-hmm.
Yeah, and now
Yeah,
this one
this one.
here.
Yeah,
Okay, I think that's all, right?
yeah. There's also a debug for that. Go there, return
Mm-hmm.
there. I didn't solve that. Also, I didn't
This
remember.
one.
Yeah, debug. I don't remember. And also, it's offsetted. It's not. It should be just below the distance measure sense.
There's a you mean
Yeah,
this?
there's some bug here. Someone put some driver between that, so it needs to be fixed. We can fix it later.
Mm-hmm.
Yeah, but yeah.
Do you think we need to debug for now?
I don't think we need that, but
Okay,
it's up to you if you want to enable it later. But I think for now,
okay.
I think because this drive is very simple. The
Mm-hmm.
more complex thing is the timer. If the timer is not working, it will not work. But except for that, everything else is very simple.
Okay, so let's uh, save that.
Mm-hmm.
Make.
I think maybe there is some also application for this example.
Do you want to check?
Mm, I'd- Maybe in the video, if you see before
In the
measuring, oh, I
in
don't
the
remember
video
if
we
I just
did
print.
yeah, in the video we didn't you didn't enable anything in the application,
Uh-huh.
and to test that you make a cat in
In
dev
the
slash I don't
okay,
remember the
yeah.
yeah.
So if I did the catch, maybe um, we'll need the debug because normally the cat will not print a string. Before that, you can open the Visual Code, the driver. Just
Mhm.
type inside drivers.
Okay, so
In the, go back to beginning. Close board. Driver sensors.
is in Arc or not? Oh no,
Drivers.
drivers. Okay, here
Sir,
sensor.
sensors and HC.
Okay,
Mm-hmm. And go to read function. Uh, yeah,
this
this
one, right?
one. Yeah, search for that exactly. Yep.
Okay, read the distance.
Yeah. There's other. Search the
Oh, yeah.
net read. This one.
Okay, that one.
Okay. Motex. Go back. Go down. Actually, get the go. Yeah, still moving down.
Okay.
Read the distance. If it's negative, there's an error. Else,
This flag here is enabled when we enable that
the debug.
debugging the.
Yeah.
Okay.
Move down.
Okay. Then it's the right.
Yeah. See, I don't see anything printing the value, and it's just returning the length.
Do you want to see a little from the video when you exactly moment when you do that?
If you want to go back there, I think it's a good idea. But because um, just to let you know, when you do cat, it's printing the uh, the the binary, the value. So the cat will print a string. So
Hmm.
normally these the cat is not working this way. So probably we'll need open some. Yeah, yeah. It just the
Okay,
cat. Yeah, we can test
let's
it,
go.
but I am sure it will not work even with the debug enabled. But okay, you can.